Wildcats. This is a short video to go over the application of discounting to future costs. So what we've been working with so far has been future investments. So for example, we have something at time zero. We typically have some outlay at time zero, so maybe minus 200,000. And then at time 1, 2, 3, 4, 5, let's say we have, I'm just going to make these things up on the fly. So hopefully they'll work. Payments then of 60,000, right? So we have an initial investment of 200,000 followed by 5 payments of 60,000. So our question would be, is this a viable investment for our firm? So if we're going to use NPV, we would need to know what the cost of capital was. So if we just say corporate cost of capital is equal to, and we'll just say 10%, so 0.1. Then our NPV, well, we could do PV of the cash flows. We can use the NPV function, NPV. We're going to rely on the rate, 10%, and then the series of future cash flows. And we got the NPV, or the PV of the future cash flows is 227. To get the NPV, we add the present value of the future cash flows plus the initial investment, and we come up with a positive NPV of 27,447, right? So that, so by our rule with the NPV is NPV greater than 0 means that the returns in the future are still exceed the value of the investment based on the corporate cost of capital. Now, one of the things we did in chapter 15 is we said, okay, well, that would be, if the corporate cost of capital is 10%, it would be appropriate to use that corporate cost of capital when we are working on a project that has a higher than average, has an average risk. If this project instead had a higher than average risk, one of the things we said in chapter 15 is we would charge ourselves a higher corporate cost of capital. So we would add some additional, we would raise the corporate cost of capital above the average corporate cost of capital to make the hurdle rate, right, to essentially raise the hurdle. So let's say this firm, the average project, therefore, would have a 10% discount rate. This firm, when it looks at projects that are slightly higher risk, maybe it adds an extra 2%. So instead of using a corporate cost of capital of 10%, it would use a corporate cost of capital of 12%. And so, as you can see, the NPV changed. The present value, well, first the present value of the cash flows changed. It got smaller, right? Because we are now discounting those future cash flows at a higher rate. And so when we use a higher discount rate, the value of those future cash flows gets smaller. The bigger we make this, right, the smaller that number becomes. If we go up to, say, 16%, I think so 16% gets us a negative return, right? So slightly higher, let's say, for a slightly higher risk, you can see that the NPV is lower. If it's 12%, the project is still viable, but when we go to 16%, the project is no longer viable. So depending on how risky this project is, you would raise the corporate cost of capital, right? You would adjust it higher to represent the fact that it has a higher risk. Okay, so this is stuff we did in class. So what I want to do now, let's go back to, say, 12. Right? What I want to do now is consider, a lot of times you're going to look at a project that doesn't have a positive return, but instead is meant to try to reduce costs. So one option would be, let's say we have, so here's a new project. Let's say it costs $200,000 today, and then the future cash flows are minus 50,000. Just make it a small adjustment. Minus 50,000. And this is gone. And so what we would have, imagine here, we're considering installing a new health record, right? An electronic health record. And these numbers are tiny for an electronic health record, but imagine we would have a $200,000 install and then $50,000 a year going into the future, right? For 5 years. So in order to install the record, we'd have to pay $200,000, and then we'd pay a fee of $50,000 each year. Alternatively, maybe we could spend $400,000, right? So the option would be you spend $400,000 at time zero. So which would you rather do? Would you rather spend 200,000 and then 50, 50, 50, 50, which is, if you just add that up, right? If you just simply add it up, okay, we're going to spend 200 and then 50 each year for the next 5 years. I want to get time zero, right? We're actually spending, if you just simply look at without allowing for time value of money, we're actually spending $450,000, which is more than the $400,000 one-time fee. So the question would be, which would you rather do? Would you rather spend $200,000 today and then $50,000 per year going into the future for 5 years for a total of $450,000 in payments? Or would you rather just spend $400,000 at time zero? And if our corporate cost of capital is 10%, then what we would do is we would say, well, those payments in the future, they're not really $50,000. They are actually, because we could save the money, right? So instead of spending $400,000 today, we could spend $200,000 today, put the other $200,000 in an investment that's earning 10%, and then we could pay $50,000 a year out of that investment. Would that be a better thing? So rather than using the NPV formula, let's look at what these actual cash flows are worth. So if we have to pay $50,000 a year from now, and we have a 10% discount rate, how much is that really worth? Well, 1 plus the discount rate raised to the number of years, right? So $50,000 a year from now is really, to this firm, is really $45,454. Let me lock the reference to the interest rate, so I can just copy this across. And I'm just going to get rid of the, whoops, wrong way. One more decimal. We don't need to have decimals. We don't care about the pennies. So it annoys me when the columns aren't the same size. Let me just clear this too. So we're doing this kind of the manual way. So what are the present value of the future cash flows? It's the same value, but I want to use this kind of more manual function to illustrate. You don't have to use this on the exam. You can use the NPV formula on the exam when you do this. I just wanted to be able to illustrate the cash flows. So if you've got a $50,000 expense a year from now, it's not really the same thing as paying $50,000 today. It's really like $45,000, especially if you have a 10% discount rate. And if you can delay paying $50,000 for 2 years, that's like having to pay a $41,000 bill. And if you can delay paying $50,000 for 3 years, that's like paying a $37,000 bill, and so forth. So when you get out to the fifth year, if you can delay paying that $50,000 for 5 years, then the cost is really to the organization is really $31,000, because they could have had that. Oh, excuse me. They could have had that money, that $50,000 invested for 5 years. So they really are paying $50,000 each year, but it's not. But because they were able to hold on to the $200,000, they were able to put that $200,000 in the bank, and it was earning interest, right? That they were then able to pay the $50,000 per year out of, right? So when we add up the present value of those future payments, it's $189,000, not $250,000, right? Because the sum of these, the sum of these 5 payments, right, as we demonstrated a minute ago, is $250,000. So if the firm is able to take the $200,000 and invest it, and then make those payments, those $250,000 in payments, that $250,000 to the firm is actually only going to cost them $189,000. And so when you add the present value of the future payments to the initial payment, you get an NPV of $389, which is cheaper than just paying $400,000 up front. So even though kind of on the surface, it looks like paying the full amount up front would actually save you money, it really doesn't, right? So that's kind of lesson 1 with future payments. So we can use the NPV, the present value concept, to evaluate not just investments where you have a positive cash flow, but also investments, right, where you have an outflow and then future outflows. And this is pretty common, right? You're going to be evaluating things like, a lot of things, particularly if you're not in a profit center. Remember, we talked about profit centers versus cost centers. So, IT, finance, HR, all those activities in an organization are cost centers. They don't have revenues. So you're going to make investments, and then you're just going to have future costs. So the idea is, how do we minimize the costs of running the HR department? How do we minimize the costs of running the finance department? Okay. So sometimes, so we're going to use, if the risk of this investment is about the same amount of risk as a normal average investment for the firm, then you would use the corporate cost of capital. Now, here's a little bit of a trick, right? What if we said, you know what, actually, this risk, let me change this. Because I'm going to mess with this in a minute. I don't want it. I need it to change. So what if we said, well, this investment, is actually a little more risky than the normal investment for our firm? Well, should we, like we did up here, increase the discount rate to represent the fact that this investment has more risk? Well, if we did that, let's see what happens. If we raise the discount rate, what happens to the NPV? So we're going to compare the NPV of this investment to the lump sum purchase option. So let's imagine that you could lease this, right? Say, and we're going to get into leases in Chapter 18, where you would pay the lease payment at the end of the year, which is kind of an unusual arrangement. We won't assume that, most likely. or most of the time with our lease discussion. But for this example, let's just stay simple, right? So we're comparing the NPV, which is the kind of lump sum at the beginning, and then annual payments versus a pure lump sum where we have 400,000 and zeros going forward, right? So here at 10% discount rate, it makes the NPV is better than the 400,000. So if you said, well, this is actually riskier, right? Meaning maybe these 50,000s are not going to be 50, maybe they're going to be 60 or 70, right? So when we or maybe they're, yeah. So that's what's meant to be represented by the higher discount rate. So if we increase the discount rate, what happens to our NPV that we're going to compare to this lump sum? Suddenly, it's actually looks like this is an even better investment, right? 380 versus 389. So it looks like the cost of financing this investment by doing 200,000 and then $50,000 in annual payments is an even better option when it's treated as if it were risky. Now, that shouldn't make sense. You should be saying, wait a minute, why would a riskier investment where we have a higher probability of failure, which is why we're using the higher discount rate, why would that be, why would increasing the risk of failure make it an even better investment? And the answer is it doesn't. And this is a one situation, one situation where you have to think about what you're doing. And here, this by raising the discount rate, it actually decreases the present value of the future cash flows. So when we do that, up here, right, where we had positive cash flows, raising the discount rate reduces the payoffs, right? It makes these payoffs less valuable to us, and forces the company to say, okay, we're going to take some more risks. So we're going to charge ourselves a higher interest rate, and basically punishes these future cash flows by making them smaller. So if we did the manual function and said, all right, well, how much are these actually worth? It's 1 plus. Right. So we have this. Wrong way again. There we go. As opposed to right. So when we apply the higher higher discount rate, the value of the future cash flows falls, right? That's appropriate when you're doing a positive investment because you want to make these future cash flows less valuable, right? You are forcing them to, because they are higher risk, you are forcing them to kind of justify themselves. But that raising of the interest rate, that we're using as the discount rate has the same effect on negative cash flows in terms of shrinking them. So because we want to punish the future cash flows and make them less valuable, when we have negative future cash flows and we want to punish them, we're not going to raise the discount rate. We're actually going to lower it. So instead of having a 10% discount rate to punish this one, we want to, instead of raising it by 2%, we want to actually reduce it by 2%. So we want to say we're going to discount the future rates by 8% instead of 10%. Right? This has the effect, if you compare these two, right? This has the effect of causing now those future cash flows to be more expensive. And that's appropriate because what we're looking to do here is reduce costs, to find the lowest cost way of doing this business. If we want to punish future cash flows, um, uh, or force them to really promise higher or lower costs, because of that additional risk, we're going to decrease the corporate cost of capital, which makes these future expenses more expensive. So comparing a $50,000 payment discounted at 10% versus a $50,000 payment discounted at 8%, you can see that the 8% one is more expensive. And so, in this case, when we have future negative cash flows and they are higher risk, that's the key. They're higher risk than the average projects for the firm. You aren't going to use the corporate cost of capital. You are going to use a lower number. You're going to adjust the corporate cost of capital downward so that those future expenses are more expensive than they would be if they were discounted back using the average risk corporate cost of capital. So this is the key point that I wanted to kind of drive home. So we're up here, we're reviewing, adjusting for risk. So this one is higher risk, right? And this one is average risk. Here we have an average risk investment in some sort of future cost, like a health record or maybe some sort of HR management program, like that allows you to do payroll or something like that. So you'd have to, that's a good example. And so this one would be a higher risk, right? Higher risk cost, right? So this is pretty close to neutral. If we said, well, it's even risk, what, it's even maybe riskier than that. If we went down to say 0.7, and then you'd say, oh, you know what, it would be better for us to just go ahead and pay the $400,000 today, as opposed to paying the 200 and then paying the 50 each year going forward. Okay. So the key difference here is when you have a future cost, right, and it is a higher risk cash flow, meaning probably it's less certain, then you would reduce the corporate cost of capital to represent higher risk rather than increase the corporate cost of capital to represent higher risk. All right, I'll post this spreadsheet along with the video.